Why does measuring things correctly matter? I am glad that you asked me that question. The reason why it matters that you record the right number of decimals is because when you're doing math with them, depending on how many decimals your number has, it will affect your answer. I get asked all the time, how many decimals should I have on this number? And in honors chem, I say 2, or I say whatever, because I don't care. But in AP, it does matter, and there is a relatively easy way to know how many numbers should be in your answer. And it's based on which numbers are considered significant and which are considered insignificant. Any number that's not a 0 matters. So, sorry 0, but whatever. 1 through 9, those all matter. And if a 0 is stuck in between two numbers, then it is a significant number. So this one right here, okay, the 3 and the 2 definitely matter. This number, that 0 counts because it's in between. So the 4, 7, 0, and 9 matter. Okay, if you have zeros at the beginning of a number, so like in this tiny one, they're just placeholders. Okay, they're not significant. They just mean that that number is really small. So if we were turning that into scientific notation, it would be written as 4.709 times 10 to the negative 3, because the first three zeros don't really matter. Kind of the same and opposite situation with zeros that end a number. If there is no decimal, then that means that those are just placeholders. So 3,200, if we were turning that into scientific notation, it would be 3.2 times 10 to the third, because those two zeros don't really matter. Okay, they're just there emphasizing this is a big number. The numbers that matter don't even start until the hundredths place. It would be different if that number were 3,200.0. What that means is someone very precisely measured exactly 3,200, and then they guessed that 0.0 because it was close enough that they felt comfortable saying it was exact. Okay, this number means someone rounded. Somebody rounded all the way up to the hundredths place. So it really could have been 3,179, and they just rounded it up. So the decimal makes a difference. This number is actually 5 significant digits, because the decimal makes all of those zeros count. This number is only 2 because there's no decimal, so those zeros are just placeholders. A little bit more practice with that. Let's say we were looking at this number. Okay, we've got a 1 and a 9 and a 0 in between. Those have to count. Okay, there's no decimal on this number, so that means trailing zeros don't count. This number has 3 significant digits. This number has a decimal, but all of the zeros are leading zeros, which means they do not count. So this number has 1 significant number. Even though this number is in scientific notation, that only makes it easier to know how many sig figs there are, because the insignificant ones have already been taken out. Okay, there is a decimal, and when there's a decimal, trailing zeros matter. So this number has 3 significant digits. Okay. So how do we use them in math? With adding and subtracting, only the number of decimal places matters. So if we were answering this question in the calculator, it would be 19.13. However, this number had no decimal points. So that means that was a very imprecise piece of equipment, and your answer can only be as good as your worst number. So if this has 0 decimal places and this number has 2, we have to get rid of both of them and round down to 19. If we kept the 0 on there, okay, so somebody was able to say that it's exactly 17, then the calculator still says 19.13. Okay, we have 1 decimal place here, 2 decimal places here. That means now we only have to get rid of the 3. So I know it seems silly to say that there's a difference between an answer of 19 and an answer of 19.1, but there is. Okay, if we took that number and did something else with it, it could affect the following math problems that we do. One more example. Okay, this is 4 decimal places. Okay, this is none. So we would have 4.0013, but since this number was rounded to 4, okay, none of our decimal places matter, and that's going to round back down to 4, so we might as well have not added anything to it in the first place. This number has no decimal places. This number has 3. So it would be 150.710. But since there's no decimal places in the first one, we would have to round to 151, because that 7 would make the 0 go up. Those would not count. Okay, it would be different if this were 1.48, oops, 1.48, I don't know where that decimal came from. If this were 148.00 plus 2.710, okay, now we're going back to this answer. Now we have 2 decimals. This has 3. Now we really only have to get rid of that one, because what we're saying is we know for certain 2 decimal places. So it does make a difference if you have 1 decimal, 2 decimals, 3 decimals, and whatever answer you get can really only be as good as your worst number. With multiplying and dividing, it makes an even bigger impact because any uncertainty that you have is compounded into the other number instead of just being added to it. So you have to consider all of the significant figures, not just the decimals. So this number has 2, and this number has 3. And a calculator will tell you the answer is 80, whoops, that doesn't look like it. That still does not look like an 8. Hold on. 87.38. Okay, but since we're multiplying, it's not just about decimal places anymore. We have to consider the thing as a whole. So since our worst number is only 2 significant figures, we have to round to only 2 significant figures in our answer. So this would be 87, and we'd have to get rid of all that left there. Okay, whereas in the second example, that 0 is considered significant because of the decimal. So now we have 3 sig figs. This is 3 sig figs. So 87.38 would be rounded to 87.4. And that number is significantly different. Okay, 87.4 compared to 87 is going to impact how close you are to whatever the correct answer is. So there will be times where we do labs and your grade is based on how close you were to the right answer. Okay, if you're writing down 87, you're going to be farther off because, everybody's going to be, the numbers are all small. So the closer you can get, the more precise you can be, the better. Sometimes this bothers people because if you have a very unspecific number, then that's going to make your answer very unspecific. This number here, 140, does not have a decimal. So that means this is only 2 sig figs, and this is 5. So regardless of what answer we get, we have to round to 2 significant digits. Calculator says 184.058, but we have to keep with just 2. So that means not only are we going to get rid of the decimals, but we have to round that 4 down to an insignificant number and say 180 is our best answer. Because that 140 was very unspecific. Okay, was it 140 or was it 136 or was it 135? You don't really know. You just know somebody rounded it, which means that your answer has to be rounded as well. The next one bothers people even more. Okay, 10,000 times 6.314. This is only 1 sig fig. So no matter how specific the calculator gives you an answer, your answer has to be very unspecific. The answer is 63,140, but if we're going down to 1 significant figure, we can only really say 60,000. That has to be the answer because all of these zeros were just rounded and guessed. There is one loophole in all of this math, which is called exact numbers. So if you're using a conversion factor to go between one number and another, you can assume that your conversion is an exact number, which means you have 0.0 to infinity. Okay, for example, an easy one. Let's say you were just converting between inches and centimeters. So 1.3 inches, this number you actually would have measured yourself or you would have gotten it in a question and you should assume somebody else measured it. That's 2 sig figs. This number is a known conversion and we're just going to assume that what that means is it's exact. So those sig figs do not affect your math at all. Anytime you're setting up a conversion, the conversion factor does not impact sig figs. So the 2 in the beginning is the only number that matters. Calculator would say 3.302, but you can only answer as good as what you started with, so we have to limit it to 2 sig figs. Okay, the 1 in 1 inch does not matter because we're assuming it's 1.00 to the infinity inches. One last example. So here's a number that might have actually been measured, okay, 4 significant figures. But this conversion, I don't want you to think that you only have 1 sig fig here, because really this is 1.0 to the infinity, because we're assuming that 1 exact kilogram is exactly 1,000 grams. So any number that you have to look up, that number doesn't count. If we did this math, it would be 4.763, and you would be allowed to keep all of those digits in your answer because the number that you started the problem with is the only one that actually matters. If all of this did not clear it up enough for you, it is in the chapter, which I have online. So check that out and answer a couple practice problems. Tomorrow we'll do a lab and some example work to make sure that we've got this down before we move on to the next thing.